Hey everybody, welcome to another live stream weekly for the DGX Spark fans out there in the world. My name is Mark Heaps, Director of Developer Marketing Community here at NVIDIA. And as you can tell by my surroundings, we are not in our usual location when we're doing this stream. We are actually live from CES in Las Vegas, the Consumer Electronics Show this week, and it has been a pretty exciting one. So actually, before I even talk anymore about CES, why don't I just let you guys see it? So Zach, producer behind the camera. All right, I think we are back after our clip there. So as you can imagine, just from the energy of that, it has been a really, really exciting week. And with regards to DGX Spark, the questions that we've been getting from attendees have just been a really positive, active, curious demand and stream of thoughts about what can I do with this when we're talking about a device like the DGX Spark. You know, many people have talked about it being the ultimate prototyping platform where you can build for local edge inference. We've seen there showing demos of, you might have seen in the video clip there, the Trinity Black car and how they're actually running inference inside of that vehicle. There's going to be a whole video feature coming from the NVIDIA team where we interview Will.i.am and his crew about the creation of that vehicle and some of the projects that he's doing with his foundation and the university in Arizona. All of that being built with DGX Spark. So that was really cool to see how they were using vision language models, using speech to text and text to speech out to run the operating system of the vehicle. Just really, really cool. So I'm looking forward to that media piece coming out. We also saw some of the physics AI demos that we were showing to the world there at our installation. And that was really cool because people didn't realize the scale of the models that you could run on the DGX Spark with the scale of memory that's available in that device. And we even had several demos running that were two Sparks actually stacked together and networked so that you could get to double that memory and utilize that for some of the larger models with better performance. So it has just been nonstop here in Las Vegas with all the curiosity about the DGX Spark. But I don't think there was any doubt that there was one major celebrity of the show that we had here, and that was our recent partnership with the Hugging Face Reachy model. And Jensen actually showed this during his keynote as well. If you haven't watched the CES keynote with Jensen, I highly, highly recommend it. It was about an hour and a half, truly inspiring, covering end-to-end the AI ecosystem that we're prioritizing here at NVIDIA. So you know what, let's take a look, because we were walking the floor. Let's actually show a little bit of what the installation looked like here at CES for that Reachy demo. It was really cool. You're going to be able to see the video interaction from the Reachy with the person on the other side. So Zach, if you could bring that up, let's show people.
Robots and physical AI are moving from research labs into everyday life. For them to truly coexist with humans, they must see us, understand us, and respond naturally.
Hello, Reachy.
Meet Sparkly, a Reachy mini robot powered by NVIDIA DGX Spark. This demo shows how developers can connect agentic AI to a real-world robot, offering a glimpse at a future where human-robot interaction feels effortless, responsive, and fun.
Excited to have you at the NVIDIA AI photo booth. I'm Reachy, and together we can design an amazing photo.
Creating these immersive experiences requires many AI models working together. Automatic speech recognition, large language models, text-to-speech, tracking, image generation, and more, often all running in real time. But here's the challenge. Most developer workstations don't have enough GPU memory or the right software stack to run this full multimodal pipeline locally without slowing down or losing quality. Traditionally, teams have faced two choices: buy high-end workstation GPUs or depend on multiple cloud APIs. Cloud-based approaches add latency and ongoing cost, raise privacy and IP concerns, and make real-time interactions dependent on a stable internet connection. That's why we built DGX Spark, a personal AI computer designed to build and run advanced AI locally, delivering up to 1 petaflop of performance and 128 gigabytes of unified memory. DGX Spark brings data center class power directly to the desktop. With DGX Spark, Sparkly runs the complete multimodal AI stack: speech, language, and vision, all on device. The result? Private data stays local, latency drops to near zero, and the interaction remains fluid and robust, even offline. Now, developers can experiment freely, iterating on prompts, behaviors, and robot motions, all within a single DGX Spark.
You absolutely rocked that photo.
What once required lab-scale infrastructure is now possible on a desk-sized system, a true embodied AI development kit.
Done with the image. Ready your camera to scan and claim your masterpiece.
DGX Spark unlocks the next generation of human-robot collaboration, where advanced reasoning, perception, and motion come together locally. It's shaping a future where robots like Sparkly don't just assist us, they understand us.
See you next time. Bye.
So as you can see, there's been a lot of work going on with the team to support some of these applications. So whether you're building with physical AI, if you're building with bots that are doing speech, the Spark is just proving itself again and again to be an ideal platform for the builders, the makers, and the doers. I was going to suggest, and I forgot to mention, around the world today, we've got teams joining us from China. We've got some folks at HQ in Santa Clara, California. We've got some folks that are joining us from different parts of Europe. So if you have questions, the technical team are actually monitoring in the chat. So if you wanted to know about the networking, if you wanted to know about the memory, if you want to know any information there, the team is actually available in the chat to be able to answer your questions. And just, I'm going to throw Zach for a loop here, but just in support of the Reachy demo, I'm going to share my screen real quick for a particular tab. Let me just bring this up, share screen, and I'm going to throw this tab in here. So the spaces that are actually available on Hugging Face, there's some really good resources in here for the Reachy Mini if you feel like getting one or building yourself and using your Spark to do that. They have different options for what the robots are, but actually if we go into the apps, I think you really get a sense of what is the scale that you can build with. So again, if you wanted to train models or if you wanted to get into certain trackers, there's a lot of work that the developer community have already done coming together in the spirit of open source and building for this endpoint, for this application. And it's amazing how much has come together in such a short period of time as a resource. So I know now that I've seen the demos here at CES that my own family is going to want a Reachy in our home, and I'm going to start working on this as soon as I get back to Austin, Texas. So with that, it was pretty exciting. There's been more things that were happening here with regards to the DGX Spark. Let me stop sharing this screen. And I want to show one of the demos that we had during the keynote, which talks about one of our other amazing services from NVIDIA, which is called Brev. And if you're not familiar with Brev, Brev is a cloud platform where we provide access to GPUs, but they partnered to build a demo with DGX Spark for this event. So I'm going to share my screen and actually show you that. So let me go back over here, push a button, push the buttons, and Let me bring this up real quick. Here we go.
Let's build a personal assistant. I want it to help me with my calendar, emails, to-do lists, and even keep an eye on my home. I use Brev to turn my DGX Spark into a personal cloud. So I can use the same interface whether I'm using a cloud GPU or a DGX Spark. I use a Frontier Model API to easily get started. I wanted to help me with my emails, so I create an email tool for my agent to call. I want my emails to stay private, so I'll add an open model that's running locally on the Spark. Now for any job, I want the agent to use the right model for the right task, so I'll use an intent-based model router. This way, prompts that need email will stay on my Spark, and everything else can call the Frontier model. I want my assistant to interact with my world, so I'll hook it up to Hugging Face's Reachy mini robot. My agent controls the head, ears, and camera of the Reachy with tool calls. I want to give Reachy a voice, and I really like 11 Labs, so I'll hook up their API.
Hi, I'm Reachy, running on DGX Spark.
Hey Reachy, what's on my to-do list today?
Your to-do list today. Grab groceries, eggs, milk, butter, and send Jensen the new script.
Okay, let's send Jensen that update. Tell him we'll have it for him by the end of the day.
Will do.
Reachy, there's a sketch too. Can you turn it into an architectural rendering?
Sure.
Nice. Now make a video and show me around the room.
Here you go.
That's great. With Brev, I can share access to my Spark and Reachy, so I'm going to share it with Anna.
Hey Reachy, what's Potato up to?
He's on the couch. I remember you don't like this. I'll tell him to get off. Potato, off the couch.
With all the progress in open source, it's incredible to see what you can build. I'd love to see what you create.
Isn't that? So, as you can see, it's just been a really exciting time to be building with DGX Spark. And I see a couple of questions and comments in the chat. Thank you guys for engaging as a community. Let me address some of these. Although I got to give a quick shout out from that video demo. The gentleman in that video is actually Nader, one of the founders from Brev when they joined NVIDIA. And he is one of the most inspiring guys that I've met since my time joining NVIDIA. We have lots of videos with him and others, so make sure you check those out on our YouTube channel. Let me address some of a couple of comments and questions that I see in here. So I'll add this one to the screen real quick. So this one from Wes Decker says, will you all be updating, releasing more Reachy mini blueprints with examples of doing everything locally like you're showing right now? Absolutely. There's always going to be more coming from the NVIDIA team here, and we believe that we are better together with our partners and with our community. We actually have the Omniverse team and the physical AI team and the robotics team that are very excited in building sort of demos and samples. And one of the members of the team from the developer advocates team, Raymond, is actually in the chat monitoring today. And he recently built some amazing robotics demos using articulating arms and more. So you can expect a lot more from us with our partners in regards of supporting these sort of edge applications and DGX Spark. So stay tuned, more to come on that, but we're all pretty excited about it. Another question that came up I saw in the chat here, let me just address this, is bring this on screen. You know, if Vera Rubin is replacing Blackwell, is it worth it to spend time learning in technologies related to Blackwell? Absolutely. You know, I think one of the things that you have to understand when you're building an AI ecosystem is that you're not building a cliff. So the NVIDIA engineers here are absolutely working hard to make sure that as we release generational technologies, those solutions not only transcend over, but then take advantage of those new architectures and efficiencies. So I wouldn't think of this as learning two separate languages or totally separate technologies. You know, these are still NVIDIA technologies, and the engineers here are developers themselves, they're builders, makers, and doers themselves, and they absolutely understand the frustrations that people would experience if we didn't consider what that flow from one part of the ecosystem into the other is. So absolutely, it's going to be supported, and you should look for more of that coming soon. And of course, that was the big announcement from the CES keynote with Jensen, was that we revealed Vera Rubin. Lots more coming on that. I don't want to jump the gun on it, but it's pretty exciting stuff, especially when you consider the efficiencies on power, throughput, and so much more. So it's a really, really exciting time. All right, the other thing, let me just sort of look over here if there's anything new in the comments real quick. All right, I see some technical questions the team are answering in there, so thanks, team, for being in there. You know what, the other part that I wanted to share from the recent updates on DGX Spark were recently published in a new tech blog by one of our leaders on that team, Alan Burgoyne. And so I'm just going to share my screen. We're going to do this live. I'm going to share my screen so you can see all of those updates. And I'll personally put the URL to this blog in the chat in case you guys want it as a resource afterwards. Let me paste that in here. Okay, so I'm going to paste that into the chat for y'all, and then I'm going to share my screen. So let's see. Share screen here. Okay. So let's go through this together so that you understand some of the updates in here. Hopefully, I zoomed in a little bit, so hopefully everybody can read what's going on here. So let's start at the top. So there actually have been some updates, new software and model optimizations to help with the DGX Spark. So we'll go through these. And again, if you have questions about any of this, drop them in the chat. The team is there, happy to answer your questions. Okay. So scaling large models, and these are some of the things that we were actually showing with demos from the teams here. So scaling large models locally with unified memory and NVFP4. So, you know, obviously one of the things that we're always trying to figure out is how do we continuously improve the efficiencies of our technologies, especially when you're getting into some of these smaller form factors, right? So when you think about running locally and taking advantage of this memory, we need to have gains in the overall output, but at the same time, we need to make sure that you can scale and maintain that speed. So I think the key thing in here, let's sort of go down a little bit, is what it means when you get this performance improvement. So let's just sort of connect in here. So for example, running a model like Qwen 235B using the NVFP4 precision and speculative decoding spec deck delivers up to a 2.6x performance increase compared to the previous FP8 execution. So again, if you're thinking about running something at the edge, that sort of speed up really, really matters when you think about low latency workloads, right? And where does that matter? Someone in the chat earlier mentioned how do we feel about having conversational language user interfaces with these endpoints, with these applications. You know, the thing that's painful when it comes to voice AI applications, or sort of what we want is a more human-like experience, is really stifled when you have poor low latency. And so this recent update with FP4 is going to matter a lot to those sort of experiences, creating a more human-like experiences. Nobody wants to wait 3 seconds for a voice to get back to you before it starts speaking. And the fact that the team here have managed to execute this while maintaining some of the precision and quality really means that I see Zach running around in the background here. That means he's got a notification for me, something happening in real time. This really means that you're going to be able to improve the overall performance of your applications. So, oh, we just got an approval to share something else, so I will show that in a second as well. Also, obviously, the nature here at NVIDIA, we believe we're better together, is this open source collaboration to get these performance gains. So this was pretty exciting. Recently, we actually worked with llama.cpp and their updates, which gave an average 35% performance uplift when running MOEs and other models on DGX Spark. So this is where we were getting a better throughput from there. And you can see the comparison from before. This chart's really nice in the blog itself, where we look back from October when we were first launching in 2025 to where we are today in January 2026. And I know the team is continuously working on this with our partners out there. We recently did a hackathon where a lot of folks were utilizing some of the SG-Lang frameworks as well. And so we're working with everybody to continually improve performance here. But this was a pretty exciting one. Let's see what we've got here. There's a desktop platform for creators. This is talking about the work that we recently did with Flux from Black Forest Labs and how we now actually have Flux 2 operating on the DGX Spark. So if you're getting into image generation, video generation, and more, really great opportunity for you there. If you're looking to get certified through some of the programs that we have with like DLI here at NVIDIA, DGX Spark is now included in the certification program. And I think this is the part that most of you care about as the builders, makers, and doers. There are even more playbooks that have been released by the teams across a swath of categories. We're talking about updates with the Nematron 3 Nano models that can run much better. If you haven't played with those models, I highly recommend them. We recently did a DGX Spark hackathon in Austin, Texas. We have another one coming up actually this month in San Francisco. So if you're a hacker and you're based in the Bay Area, you should definitely come check that out. That's going to be the weekend of January 23rd, 24th, and 25th. And you can look at our Luma calendar to find out more about that. So yeah, all kinds of things going on in here, from Nematron 3 Nano to vision language models. Obviously, if you're into robotics, getting the Isaac Sim Lab, the work that we're doing with SG-Lang and VLLM is just really, really awesome. So I won't go through all of these, but this blog is available to you. This is something that you should definitely check out. And just closing on this one, the NVIDIA Brev demo that we showed earlier, there are some launchables available to talk about exactly what Natter was demoing in that video. So we're not just actually doing a little video performance there. The resources are now available to you. So check that all out as well. And then one last thing that actually was just kind of a fun personal moment for me during CES was that we had a special guest there. And so many of you might not actually know, but the producer, artist, fashion designer, creator known as Will.i.am from the group Black Eyed Peas was actually at the show. And many people don't know that he is actually an extremely experienced technologist. Does a lot of his own developer work. He's very knowledgeable about AI and LLMs and multimodal and so much more. So at the start of the video we showed earlier was his new product that he's experimenting with called Trinity, which is this 3-wheeled vehicle that they were showing at the show. What's really cool about the Trinity is it's powered by DGX Spark. So thinking of, it's not an autonomous vehicle, I want to be clear about that, but it's actually running the operating system of the vehicle on a single DGX Spark, which was really cool. So I think producer Zach in the background here can actually show.
We're here with the developer. Hey everybody, we're here with the developer community live stream, and I've got our special guest, Will.i.am.
What up, bro?
Artist, creator, maker, builder, technologist, and all things. What are you showing the world here today? I see this amazing vehicle behind us with Trinity.
Yeah, it's a company that I started, self-funded. It's a Trinity. It's a singular passenger micro vehicle, 0 to 60 in under 2 seconds, 800 horsepower,
wow.
400 horsepower on each wheel in the back. Weighs about 2,000 pounds.
Oh,
we got a DGX as its brain. It's literally brains on wheels.
Nice.
We self-drive. The DGX controls all the vision model. The LLM, our agentic radio station where the agent hosts and goes in between segment to music. It's a crawler. It's a freaking awesome reason machine.
Yeah.
You got in workflows in there, MCP protocols, all happening on device.
So that is a sneak peek of a full feature interview that's going to be coming from NVIDIA very, very shortly. They did a whole long conversation with him about the technology, breaking it down, how is it actually running. I was floored having the conversation with him to realize how approachable building is today. Him and I had a long conversation about how developers today are the Renaissance artists of this generation and era, and he truly believes that. He was so excited. He's actually got a new professorship starting at University of Arizona, and his students are in a partnership with NVIDIA for building on our GPU technology. They're going to be working with Sparks as well. And that was just really, really exciting to hear. He talked about how they've implemented agents inside of the vehicle, again, running locally on the Spark, so that it not only is a voice-operated controller, but it's building playlists in real time. It's actually coordinating with you on your GPS. It was running vision language models to detect the area around you. That was cross-referencing the GPS coordinates through an API with a remote connection with your phone. Absolutely floored by this thing. And just to see someone that has the platform like Will.i.am out there promoting the developer community, I was totally floored and totally blown away. So deeply inspired by that one. I look forward to sharing more from that interview here in the coming weeks. I'm going to look at a few more questions that are here in the chat today. I see someone, let's see, 100 Tensor said, London, only if you promise the conference comes with fish and chips and a royal wave. I don't know how good I am with the royal wave, but I can tell you the developer community is actively looking at new opportunities to join the developers around the world. We're looking at London Tech Week right now, and we've got so much more coming. So we're getting back out there where you guys are working, and we're looking forward to meeting everybody very, very soon. And again, I mentioned earlier the DGX Spark hack series is happening right now. We did one in Austin, Texas. We're doing another one in San Francisco on January 23rd, 24th, 25th. And that is working with our OEM partners. These are the other corps that are actually building their versions of the DGX Spark. The one coming in San Francisco is actually in partnership with Dell. And we will have members of the ASUS team there because of the, or sorry, not the ASUS team, the ARM team there because of the ARM CPU inside of the Spark. And you'll be able to get questions answered there about the CPU and GPU technology that are inside their GB10 device. So if you've got a team and you think you can build something with open data using open models, let us know. We'd love to actually have you there. And we're going to continue working with other OEM partners as we bring the Spark series forward. I mentioned ASUS because they actually partnered with us on the first DGX Spark hackathon in Austin, Texas, and we're looking for new locations to do more. So more to come on that. Stay tuned. Let's see if there's anything else in here that we didn't cover for today. All right, it looks like the team is in there answering questions. This is very cool. All right, well, I think in that note, we are in a very good place to call it this week. Thanks everybody for joining us for this week's DGX Spark live stream. We will be back with our normal setup next week with members of the team. Thank you for letting me join in. And as always, keep building, keep making, keep hacking, and keep joining in the open source AI ecosystem for NVIDIA. We will see you guys next time. Thanks so much.